This is surface area of pyramids and cones. This is almost the same thing as prisms and cylinders, but prisms and cylinders have two bases where pyramids and cones only have one base. But other than that, it's kind of the same. It's kind of sort of. So a pyramid is a 3D figure with one base that is a polygon and lateral faces are triangles. We went over this kind of stuff in 12.1, but just the recap. The vertex of the pyramid is the point where all the lateral faces intersect. The height of a regular pyramid is the distance between the vertex and the center of the base. And then there's the slant height of a pyramid. It is the length of the altitude of the lateral faces. So when you're talking about slant height, you're just looking at the triangle on the side of the pyramid, and then it's the perpendicular height of the triangle, not of the whole pyramid. So the way I note these to remember is the height of the pyramid is on the inside. It's inside of the pyramid because it says from the vertex and the center of the base. So it's inside the pyramid. So if you were inside the pyramid and you wanted to go to the top and there was an elevator in the center, it would be the elevator. But if you were visiting a pyramid and you were on the outside of the pyramid and you wanted to go to the top, you would take the stairs. So the slant height of the pyramid is on the outside. So it's like the stairs on the outside. So that's how you, and most of the time you're going to be needing the slant height of the pyramid, unless it's just some odd question that's asking you for the true height. So the slant height is on the outside. So in this diagram here, it's this one, and you can see that it is on the outside of the pyramid. So your formulas for the regular pyramid is the lateral area, L or LA. That's the way I did it in the last notes. So L equals half of the perimeter times the slant height. So here P is the perimeter. Of the base. So whatever shape the base is, it's not always a square. This one is a square. It could be triangular. It could be a hexagonal pyramid. If it was a hexagonal pyramid, you would have 6 sides, and then you would add up, you'd have the length of a side times 6. This one is a square because it says square pyramid, so it would be the length of the side times 4. If it was a triangle, the perimeter of the base would be the length of the side times 3. Well, for a regular pyramid. And then L is the slant height. On the outside of the pyramid. So once you find the lateral area, you can use that to calculate the total surface area. Because see the half P, half the perimeter times slant height, that's the first part. And then you add the area of the base. The area of the base changes. What formula you use for area of the base changes depending on what your shape is. So this B, area of the base, the formula changes based on the shape of the base. want to say based, according to shape of the base. I remember looking at papers for prisms. People were consistently using the triangle formula for the area of the base. But if you have a rectangular base, you can't do area of a triangle. You need area of a rectangle. Base times height, length times width. So that's important. That's why pyramids and prisms are a little trickier than cylinders and cones, because cylinders and cones, the base is always a circle. So you always use a formula for a circle. But pyramids and prisms, it can be any shape. So you have to make sure you're using the correct formulas. All right, so now I decided to go ahead and cut off number 1. We're not going to do that one. And this tells you this is a square pyramid. So my base shape is a square. So I'm going to use, when I do area of a base, it's going to be length times width, because it's, or side squared, because a square is a rectangle. And perimeter, I'm going to have 4 sides because it's a square. If it was a different shape, I would do this slightly different. All right, so the lateral area and the surface area of this square pyramid. So first, I'm going to set it up as the surface area. The lateral area. We want to do that one first, or L, equals 1/2 of the perimeter times the slant height. All right, so I need to figure out what is the perimeter. Well, I see I have a side length of 6, and I have 4 sides. So I'm going to say 6 meters, because that's the side length, and then there's 4 sides. So times 4. So it's 24 meters. So the perimeter is 24 meters. And then I need the slant height, L. Well, since it's given to me in this problem, it's right here. That makes it pretty easy. It's 5 meters. So I'm plugging those into the formula. So the lateral area is half of 24 times 5. 24 meters times 5 meters. So the lateral area is 60. And since I have meters times meters, that's meters squared. And area should have units squared, and it does. So that kind of checks out. So the lateral surface area, or the lateral area, is 60 meters squared. And then I can use that to find the total surface area. S equals L plus B. I know L is 60 meters squared, so S equals 60 meters squared plus the area of the base. So I need to figure out what is the area of the base. Yeah. So I'm going to treat a square as a rectangle because a square is a rectangle. And since this is a rectangle, it's length times width, or base times height, however you want to look at it. It's a rectangle. 6, the other side's 6, so that's 6 times 6. So the area of the base is 36. These are meters squared. So 36 meters squared. So I have meters squared plus meters squared. Those are like terms. So the total surface area is 96 meters squared. Again, be careful on which formula you use for perimeter and for area of the base. It's told me that was a square pyramid, so it's a rectangle base. It's this shape here. Whatever it is, you use the area formula for this shape. All right, so that is an example of a pyramid. And then on the back, we're going to look at cones. So a cone is a pyramid that has a circular base. So the formulas for a cone lateral area is pi r L. R is radius, L is slant height. And then surface area, you take the lateral area and then add the area of the base, pi r squared. So we have r is the radius, and L is the slant height still. So on a cone, the slant height is same as on a pyramid, it's on the outside. And the radius has to go from the middle to the edge. That's the radius. All right, so looking at this example, I'm going to do number 1. Can't really see that, so I'm going to outline the circle. There we go. So I'm given the radius. I can see that the radius is 8. So I have r equals 8 inches. But I don't know what the slant height is. It's not given. It has to be the outside. It gives me the true height, the perpendicular height, the elevator inside the cone, but it doesn't give me the stairs, the slant height. We have to take the stairs. All right, so we have to do, what are we going to use to solve this? What's that shape? It's this one right here. It's a right triangle inside, right? And what is that one thing we keep doing all year long with right triangles? The Pythagorean theorem. Yes, Pythagorean theorem. A squared plus B squared is C squared. So 15 squared plus 8 squared equals L squared. Eight squared plus 15 squared in the calculator gives me 289. L? Slant height. You can put C if you want to. I put L because it's the slant height. I use a cursive L because if I used a regular print L, it would look like 1. Basically. Yeah, but it's an L. It's a cursive L. So 289 equals L squared. So the square root of that would then equal L. So the slant height is 17. Oh. Yes, the fish is 17. So it's 17 inches because that's a linear measurement. So we have the radius and the slant height, 8 and 17. Now that we have those two values, we can go ahead and solve for the lateral area. So now I'm going to set that up. Lateral area equals pi times the radius times the slant height. Since I know that the radius is 8 inches, and I know that the slant height is 17 inches, I can multiply it out. And I'm going to first put it in terms of pi because you need the lateral area in terms of pi to calculate the surface area. So L equals 8 inches times 17 inches is going to give me 136 inches. So 136 pi inches squared, because inches times inches is inches squared. And that I will need to calculate total surface area, but for my final answer for lateral area, I'm going to use a decimal, unless your instructions in your assignment tell you otherwise. 427.3. Long class. Inches squared. All right, so then I found the lateral area. So if I want to find the surface area is L plus area of the base. I'm going to do it that way. And I have that, so I can plug it in. So S equals 136 pi plus area of the base for a circle is pi r squared. So pi r squared. And we know the radius already because we already used it. It's 8. So then the total surface area is 136 pi plus 8 squared is 64 pi. So that gives us 200 pi. And these are inches squared. So as a decimal, 200 pi is 628.3. And these are inches squared. All right, so I'm skipping the second example.
You don't have to put everything in pi, right? You can just use the 427 and 420.
For your final answer, you can use the decimal, but you don't want to use 427.3 when you're calculating the total surface area because you rounded that. That's not an exact number, so your answer will be off by a little bit if you use the rounded decimal. That's why we do in terms of pi and then the answer. All right, so then what is the slant height of a right cone with a radius of 3 centimeters and a lateral area of 21 pi centimeters squared? Okay, so I could see we're talking about a cone. So that's important because that tells us which lateral surface area we have. So this is the lateral surface area, 21 pi centimeters squared. That's L. Right cone tells me which formula I'm using. The formula for a lateral surface area of a right cone is L equals pi RL. I have the slant height. What is the slant height? That's what I don't know. So I'm trying to solve for the slant height L. And I do have the radius of 3. So R equals 3 centimeters. Let's see, I can write that out. L equals 21 pi. So I have 3 things. So, okay, so I'm going to go to the formula. L, I have L. L is 21 pi centimeters squared. And it says that equals pi times the radius, which I have the radius is 3 centimeters. And then times the slant height. So since I want to solve for the slant height, L, I want that by itself. So since I have other stuff that's being multiplied by it, I want to undo the multiplication with division. I need to get rid of this pi, so I'm going to divide by pi. I need to get rid of this 3 centimeters, so I'm going to divide by 3 centimeters. So the pi's cancel, the 3's cancel, and the centimeters cancel. But as always, if I do it on one side, I have to do it on the other side also. So look at the bottom, everything I have down there, I have a pi. I'm going to go ahead and line that up underneath the other pi. I have a 3, I'm going to line that up underneath the other number. And I have centimeters, so I'm going to put that under the other centimeters. So the pi's cancel. I have 2 sets of centimeters on top, and I have 1 set of centimeters on bottom, so I can cancel the one on the bottom and cancel one of them on the top. And then I have this 21 over 3. Well, I can't just cross it off, but 21 divided by 3 is 7. So I could call this 7, and then I had 1 set of centimeters left. And that equals the slant height. All right, and then the last one is the effect of changing dimensions. This one's a little different from the last one that we went over Wednesday. If the radius of a cone is multiplied by 4, what will the area be multiplied by? So we'll just pretend that this is, again, L. So if I had L equals pi r L. And I'm going to multiply the radius times 4. So how is that going to affect the L is the question, the area. Well, the answer is it will also be multiplied by 4. So only one dimension or one piece is multiplied by 4. So the area also changes by times 4, not by 16. Remember, like the one from the other note said, if I change, what was it, the radius and, what was the other thing? And this, it would say radius and slant height. If we change both dimensions, then how does it change the area? Well, if you change both dimensions, if I were to change both dimensions in this problem, the radius times 4 and the lateral and the slant height times 4, that would equal changing the lateral area by 4 times 4, which would be by 16, because these would be balanced, the same amount on both sides. But I didn't change both dimensions. I only changed the radius. So to keep it balanced, I'm going to multiply that by 4 also, not by 16. So the area changes according to what's being changed, how many dimensions, how many pieces are being changed on the other side of the equal sign. Oh, there should be a y in there. Pi times 4.